Hello students. Today we are going to discuss on chemical bonds. Chemical bonds, unit number 10 in grade 10. So I am going to summarize this lesson. So we'll see what is chemical bonds. In simply, what is a chemical bond is, these are the attractive forces among the atoms or ions. There are two types of bonds, you know that. We have learned this before. What I am doing is summarization, ionic bonds and covalent bonds. Let's see what is an ionic bond. So you know, certain atoms, the neutral atoms, they become positively charged by donating electrons. And certain atoms, they become negatively charged by gaining electrons. And we have learned in the structure of atoms about polyatomic ions. So there are positive polyatomic ions and negative polyatomic ions. NH4 plus, SO4 sulfate, ammonium, nitrate, NO3 minus, phosphate, PO4 3 minus, and so on. So what is an ion? Ion is actually the charged atom or charged group of atoms, maybe positively charged or negatively charged. So ionic bonds are formed due to the strong electrostatic attractions between positive and negative ions. So ionic bonds are made between positive and negative ions. We have learned that the positive and negative are opposite charges attract each other. So same charges repel each other. So the opposite charges attract each other. So when you have ions, positive and negative ions, they attract each other electrostatically. So they make a compound or a bond. We say ionic compound. So sodium, for example, sodium will donate 1 electrons and they become sodium ion, positively charged ion or cation. Chloride ion, the chlorine, they gain 1 electron and they become chloride ion, negative ion. So negative and positive charges attract each other and they make a compound called ionic compound. So these ionic compounds or these ions are not single ions. There are moles of ions are combined together. Moles means a huge number, we will learn in the next lesson, right? So not a single ion is found here. So these ions are combined together. For example, if you take sodium chloride, it is not a single compound. It forms a lattice, ionic lattice, like crystals. So these are actually 3D structures, 3-dimensional structures that they are connected. For example, this one sodium ion is connected with 6 chloride ions, top, bottom, left, right, front, back, in 3-dimensionally. If you look at a chloride ion, it is connected with 6 sodium ion. So likewise, they make this lattice. අපි ලුණු කැටයක් ගත්තම sodium chloride can salt crystal එක ගත්තම they have this kind of a structure. They form ionic lattice. So remember, ionic compounds make ionic lattice. So this, when you look at this structure, you should be able to identify whether it's an ionic lattice. This is sodium chloride. So remember. So now we said the ionic compounds are made between positive ions and negative ions to attract each other. So they make the ionic bonds. Generally, remember, metals, we learned in the previous session on structure of matters, the metals always donate electrons and they become positively charged. Non-metals, they always gain electrons and they become negatively charged. So generally, the ionic bonds are made between metals and non-metals because the metals become positive, non-metals become negative. For example, sodium chloride. Sodium is a metal, chloride is a non-metal. So sodium becomes sodium plus, chloride becomes chloride minus. Magnesium chloride is an ionic compound. Why? Magnesium is a metal, chlorine is a non-metal. So likewise, there are so many examples you find with ionic compounds, the metal and non-metal. Except there are certain instances where the metals and non-metals forms not ionic compounds. They form covalent compounds. For example, aluminium chloride. So aluminium is a metal, chlorine is a non-metal, but remember it is not considered as ionic compound. They are covalent compounds. We will learn what is covalent compound. And usually the polyatomic ions or radicals, in other words we say radicals, form ionic compounds. What a carbonate means CO3 2 minus, they are negative ions. Hydroxide ions, these are polyatomic ions, so they also make always ionic compounds. So whenever you see a polyatomic group, polyatomic ionic group or radicals, so they form ionic compounds. So remember, ionic compounds are made between ions, positive and negative ions. Usually the metals and non-metals between, except certain examples like aluminium chloride, beryllium chloride and beryllium fluoride are not ionic compounds. And the ionic compounds are made between polyatomic ions. So whenever you see a compound with polyatomic ion, they have formed ionic compound. So in your tute, I have given this 39th question on draw the atomic structure of sodium and certain compounds and certain ions with their energy levels. So I'll quickly go through it. So sodium, you know, that is 281. So in the first shell 2, so this blue color ball represents the nucleus, so it's a positively charged. So this dot represents the middle of an atom, that is protons and neutrons. So I just wanted to show you the shell structure of electrons, how they are configured, how they are filled. So in the first shell 2 and these 8 and 1 sodium. And then lithium, this is the shell structure of lithium, 2 and 1. You should be able to draw it, or you should be able to identify whenever you see the structure. Based on the number of electrons, you can identify them. Tunak tiyanona nang, that is 2, 1, that is lithium, 3. Atomic number is 3 in case of neutral atoms. Chlorine is a neutral atom here, it is mentioned. So 287, that is 17. So you can identify it's chlorine. When you look at this structure, you should be able to identify the atom, a particular element. Fluorine, 27, its number is 9. So I said in the last class, if you don't remember these 20 elements along with their atomic numbers, chemistry, forget about chemistry. Because you don't understand anything, it's very difficult for you to go ahead without memorizing these 20 elements along with their atomic numbers. So fluorine is 9, so configuration is 27. So this is how the electrons are filled in its structure, energy levels. This is calcium 2 plus. So 2 plus means that they have donated 2 electrons. Plus kiyanne dila. They have given 2 electrons. So earlier it was 2882. Now it has become stable. It has made a stable configuration by 288. 2 plus. 288 2 plus කියන්නේ දෙකක් දීලා තියෙනවා. එතකොට මේ කැල්සියම් ගේ ස්ට්‍රක්චර් එක. අපි හිතමුකෝ 1 plus කියලා. 1 plus නම් අපි දන්නවා 288 and 1. That is potassium. මේ iron එක දැක්කත් the cell structure එක plus minus දැක්කත් අපිට හොයාගන්න පුළුවන් වෙන්න ඕනේ which element is with that particular structure. For example, another one, sodium plus. So this is the structure plus. That means the original, before it becomes iron, it was 281. Now 1 is gone and 28 is here. So this is sodium. So sodium plus. If it is 2 plus, the same structure with 2 plus, can you guess what is the element? Again, දෙකක් දීලා තියෙනවා. Now 2, 8 and 2. That is magnesium. Chloride, that means they have gained 1 electron here. Earlier it was 287. Now 1 electron is collected again. So it has become 288. Now 18 number of electrons are 18. So oxygen, O2 minus. So you can just draw the structures. This is shell structure for a compound, ionic compound, sodium chloride. So here when you draw this structure, so remember sodium plus, have to show this in this way, structure plus, bracket එක දාලා plus දාන්න ඕනේ, and chloride is, you have to show it in a bracket, and they have gained 1 electron. Now the bond is represented here. So this is how you show the bond. මේ bond එක පෙන්නන්න. Ionic bond between ions. Similarly, lithium fluoride, lithium plus, fluoride minus. Lithium has donated one electron and they have become plus. Put it in a bracket and show fluoride iron එකක් පෙන්නනකොට bracket එක දාලා පෙන්නන්න මෙතන මේ minus the positive ද කියලා. Fluoride ion, now they have made a ionic bond. So this is how you show the ionic bond here. Calcium oxide. So calcium 2 plus. So to become stable, it donates 2 electrons and it becomes 2 plus calcium cation or positive ion with 2 electrons are donated. O2 minus, they have gained those electrons and then O2 minus, and this is how the compound is formed. Ionic bond is made between them. Now, can you draw the shell structure for lithium oxide? Please hold the video. Try to get it, please. And බලන්න පොඩ්ඩක් අර විදියට. So in this case, which element to be made in the middle? Single තියෙන කෙනාව දාන්න. Oxygen දාන්න as the middle. Right? Oxygen දාන්න මැදට. And both either side of the oxygen you can indicate lithium. Try it, please. So this is the structure of lithium oxide. So how this Li2O is made, that is due to the chemical formula. You know, lithium has valency 1, oxygen has 2 valency. They have switched them and you get the final formula as Li2O. So now there are 2 lithium ions, right, and oxygen ion. So oxygen needs 2 electrons, and they have gained one from one lithium and the next electron from another lithium. So this is what they have made the bonds. So there are 2 ionic bonds here. So just practice this and you will get in your structure papers especially to identify these elements and to represent whether they are positive or negative, to mark them. So when you come to the physical class, we will do these past paper questions based on the theory you learned. And then next is the ionization reaction of sodium plus, chloride minus, Mg2 plus, and so on. Let's see how to write the ionization reaction. So the whole thing, what you represent here, the ionization, we can show it in a simple way by using an equation. මේ මුළු කතාවම මේ මුළු ස්ටෝරි එකම අපිට පුළුවන් මේ වගේ equation එකකින් පෙන්නන්න ionization එක. Ionization means becoming an ion from a neutral atom. So sodium donates, reducing, or they donate 1 electron. So you have to subtract 1 electron and they become sodium plus. So this is how you show by an arrow the chemical, or we say this equation. But generally minus E, we don't keep it in this form. We will take this minus E to the other side, then it becomes plus E. This is the standard form of writing ionization equation. මේ minus E එක අපි අර පැත්තට අරගෙන මෙහෙම තිබ්බත් අවුලක් නැහැ. No problem. But this is how we draw. So මෙන්න මේ විදිහට ලියලා පුරුදු වෙන්න ionization reaction එක minus E එක අර පැත්තට ගෙන යන්න. Take it to the other side. Plus E and keep it like this for the positive ions. You can practice this with magnesium. They donate 2 electrons to become stable. 282 නේ දෙකක් දෙනවා. So 2 electrons are donated. So take the minus 2E to the other side plus 2E. Likewise, you can practice for the potassium as well. Chlorine, you know that they have 287 the configuration. They are gaining 1 electron. එතකොට plus E මෙතන දැම්මට ආය අර පැත්තට ගෙනියන්නේ minus E කරන්න. You keep it as this for the negative ions. Cl minus. Fluorine gain 1 electron, fluoride ion. Oxygen takes 2 electrons to become stable. So they become O2 minus. So this is how you represent the whole phenomenon, whole of the stories, the ionization stories, in a single equation. So this is called ionization equation. Next, what is a covalent bond? We said there are 2 types of bonds, ionic bonds and covalent bonds. So what is a covalent bond? In this case, the bonds or the attractions are not between ions. So the attraction are between atoms here. So none of the atoms become positive or negative charge here. So how they make this bond? By sharing electrons between atoms. What is this? Or how do they share? So as I said before, that atoms, they do not stay as neutral, unstable. They always try to become stable. By donating electrons, by gaining electrons, another way of becoming stable is sharing electrons. To share the electrons, they can join together. They should come closer. So we will detail further in the next slides. So remember, the covalent bonds are not between ions, between atoms only. So that another very important point is that usually the bonds between non-metals, they form covalent bonds. Non-metals la hadanne covalent bonds. For example, H2. H2 means they have made hydrogen and hydrogen. They have joined together. F2, fluorine and fluorine joined together. Not the ions, not fluoride and fluoride here. Fluorine atom and a fluorine atom. Chlorine, Cl2, N2. So all of these you see are non-metals. That is except aluminium chloride, beryllium chloride and beryllium fluoride. You know that although they are metal and a non-metal, but they still forms covalent bonds. The beryllium is a metal, chlorine is a non-metal. Ionic නෙවෙයි. But මේගොල්ලොත් හදනවා covalent bonds. Not all the non-metals form covalent bonds. Most of them form covalent bonds, non-metals, but except few. And similarly, not all the metals and non-metals make ionic bond, but most of the metals and non-metals, between the metals and non-metals, they make ionic bond except few. So now you should be able to identify whether these bonds are ionic or covalent. For example, sodium chloride, you can recognize it's a metal and a non-metal. It's not that aluminium chloride, beryllium fluoride or any other exemptions. So sodium chloride is between metal and a non-metal. They usually become positive and negative charges, ionic bond. Sulfate, copper sulfate. You know that it is a polyatomic ion. I said polyatomic ions make ionic bonds. Water, H2O, all non-metals here. That is covalent bond. Ammonium chloride. Ammonium plus is a ionic polyatomic ion, so they make ionic bonds. NH3 is a different case. That is not a polyatomic ion. That is a gas made between nitrogen and hydrogen. So this is covalent bond. So likewise, you can get the answer here. Go through this and you can identify now easily the ionic and covalent compounds. For example, HCl, hydrogen and chlorine between non-metals, covalent. But aluminium chloride, as I make aluminium chloride is metal and non-metal but still covalent. And they are also incomplete octet. I will explain later on what is incomplete octet. They also make incomplete octet. Cl2, between Cl and Cl, non-metal, covalent. Sulfate, sodium sulfate, ionic. N2, covalent. NH3, covalent. PCl5, covalent, between non-metal and non-metal. And another example for incomplete octet is PCl5. I'll explain what is incomplete octet. So what do you think about this molecule? So you know glucose. So glucose molecule is ionic or covalent? Can you guess? Yes, it is covalent. There is no metals found here. These all are non-metals. They usually make covalent bonds. Sucrose, sugar. The white and red sugars. Sucrose, your table sugar found in your kitchen, in your house. Make a covalent, ionic. Covalent. C8H18, carbon and hydrogen, is a petrol. So generally compounds containing carbon and hydrogen, we say hydrocarbons. So this petrol, kerosene, diesel, right? All these LP gases, we say all are hydrocarbons. So all these hydrocarbons, remember, they make covalent compounds. Well, they make covalent bonds and they are covalent compounds. Petrol. Kerosene, C12H26, kerosene, that is also what? A covalent compound. So they are hydrocarbons. Now take a look at how these covalent bonds is formed. But then quickly I'll explain you how these covalent bonds are formed. Ionic bonds, you know that, between ions. So one element will donate electrons, become positive, the other electrons gain other atom that gain electrons and they become negative ions, and between them electrostatic attraction, they form the ions, and we have studied now how these structures are formed. As far as the covalent compounds are concerned, I said they are not making any ions here, they are sharing electrons. Look at this. For example, fluorine atom. Fluorine is, you know, I don't know fluorine කියන්නේ number 927. 27. So in the outermost shell or valence shell, it has 7 electrons. So you see, generally the electrons are presented as pairs. So the one is here, they need one more electron to become stable, right? And this fluorine also need one more electron. දෙන්නටම need එකක් තියෙනවා. කවුරුත් දෙන්නේ නැහැ. Now what they do is they will make a deal here now. Look here. මෙයා කියනවා ආගේ එකයි මගේ එකයි අරගෙන we will share these two electrons which is common for both of them. So they will make a set here. You have learned in mathematics. Set එකක් හැදුවම මෙතන intersection එකක් එනවා. So intersection means common for both. It's common. So now these pair of electrons are common for both the fluorines. Now look at this one fluorine atom in the outermost shell. It is completed. By sharing electrons, they became stable. Look at the other fluorine atom. එයාත් මොකද කරලා තියෙන්නේ? එයාටත් මේක common වෙනවා. එයාගේ 2 4 6 8 වෙලා complete වෙලා. Now they have satisfied. They have made the octet. Now they became stable, but not by donating or gaining, by sharing one of the electrons of both. Right? ඒ කියන්නේ මේ දෙන්නගෙම electron එක ගානේ අරගෙන electron pair එකක් හදාගෙන තියෙනවා common කරගෙන දෙන්නටම. So this is how they make covalent compounds, by sharing electron. They sit together and they make like mathematics intersect කරගෙන share කරගන්නවා. Now certain terms are very important in case of covalent bonds. So those electrons pair which were shared among them, so this is the pair responsible to make the bond. දෙන්නම ලං වෙලා හදන්න contribute කරපු මෙන්න මේ electron pair එක තමයි bond එක හැදුවේ. This pair is called the bond pair. So the bond pairs are the pair of electrons participated to make the bond. The bond pairs are the pair of electrons participated to make the bond. Look at the මේක බලන්න පුතා outermost shell එකේ in this fluorine and the next fluorine, both the fluorines outermost shell, only in the outermost shell there are pairs of electrons that are not participated for the bond, to make the bond. outermost shell එකේ තියෙන valence shell එකේ තියෙන participated දුන්නේ නැති the electrons pair that are not participated to make the bonds are called lone pairs. අපි මේවට කියනවා පුතා lone pairs කියලා. We say lone pairs. අපි මේවට කියනවා lone pairs කියලා. මෙන්න මේක මතක තියාගන්න lone pairs. Lone pair means those are the electrons, pair of electrons. There are two electrons here. One pair means two electrons that are not participated. So the bond pair means there are two electrons, remember. Each pair has two electrons. ඔන්න ඕක මතක තියාගන්න. Now, how many lone pairs are found in fluorine atom? In one fluorine atom? In one fluorine atom, there are three lone pairs. Three lone pairs. ඒ බලන්න තුනක් තියෙනවා එක fluorine එකක. එතකොට F2 molecule එකේ තියෙනවා 6ක්. Right? Now let's see how many bond pairs are found in F2 molecule. So we saw that there were 3 lone pairs for each fluorine atom, and altogether in F2 molecule 6 lone pairs were found. In one fluorine atom we had 3 lone pairs. In a F2 molecule, how many bond pairs are there? Yes, there is only one bond pair were found. මේක ගත්තම මේ තියෙන bond pair එක. Only one bond pair, right? So there are only one bond pair. So now we will see the Lewis structure of F2 molecule. That was the representation of shell wise or energy level wise, how they made this bond between these fluorine atoms. And now we'll see, to make it easy, so there were scientists, they have proposed with different structures to represent the covalent bonds. So Lewis structure. So first of all, we see the Lewis structure of F2 molecules. So the same, this shell structure is now we are converting to Lewis structure. In case of Lewis structure, what they say is this bond pair is indicated as a line, represented as a line. මේ bond pair එක පෙන්නනවා line එකකින්. මේක line එකකින් පෙන්නනවා. The lone pairs are represented as dots. මේ තියෙන අන්තිම lone pairs I explained, the outermost shell එකේ තියෙන not participated to make the bonds are the lone pairs. So the lone pairs are indicated as dots like this around this fluorine atoms. මෙන්න මේ වගේ අපි පෙන්නනවා lone pairs tika. Right? So there are 3 lone pairs in one fluorine atom. So this is how they are shown. So this is called the Lewis structure. The bond pair as a line, the lone pairs as dots. So the same thing, we can convert this into dot and cross diagram. Another way of representing these covalent bonds are as dot and cross diagram. When Lewis diagram, what the dot and cross diagram says, the electrons in one type of an atom as dots. So one fluorine atom we show as dots. Electrons in the other type of the atom. Or here we have the same type but 2 different fluorine atoms. So the next fluorine atom has to be shown. The electrons are shown in crosses. Make up cross වලින් පෙන්නනවා. So this is the bond pair. මේ මැද තියෙන එක bond pair එක. So this bond pair means shared electrons. So one dot and one cross. එකක් මෙයාගේ electron එක අනිත් එක මෙයාගේ electron එක. දෙයාර දෙන්නගේ මේ electron තියෙනවා. මේ line එකෙන් හැම වෙලෙම පෙන්නන්නේ පුතා dot and a cross. So the line indicates a dot and a cross in case of dot and cross diagram. එක line එකකින් electron දෙකක් තියෙනවා. Right? So remember that. So this is how you draw the dot and cross diagram, and there is another method called Lewis dot diagram. In this case, all the electrons in bonds and electrons, the lone pairs, all are indicated as dots. මේක දැන් ඔක්කොම ටික අපි cross ටික අයින් කරලා dot වලින් පෙන්නනවා. So there were 3 methods we explained. Lewis structure, bond pairs as line, lone pairs as dots around the atom. Dot and cross diagram. So one type of a atom as dot, the other as crosses, the electrons. So remember, in a bond pair, usually you have a dot and a cross. I'm available line again dot and cross because that's a bond pair, no shared ones. In dot diagram, we show everything, all the electrons in dots. So these are the 3 methods of drawing the diagram. So likewise for hydrogen atom, covalent bonds, you see hydrogen 1 electron in the outermost shell, they need 1 more, so they make a bond here, they share the electrons, they make a set. Share කරගන්නවා දැන් දෙන්නම. එතකොට දැන් there is no lone pairs, you see here. Around the hydrogen atom there are no lone pairs. Only one bond pair is found. So the bond is represented as a line in Lewis structure. There is no lone pairs. Dot and cross එකට ඒකම convert කරනවා. එක line එකක් මම කිව්වා dot and cross කියලා දාන්න. Lewis diagram, a dot diagram, all crosses, everything in dots. Take a look at water molecule. So now oxygen is, you know that oxygen is 2,6, number 8. So it needs 2 more electrons to become stable. So they are going to share with 2 hydrogen atoms. From them, each hydrogen has 1 electron. So they are going to share these 2. They are going to make a deal here. Set එකක් දා ගන්නවා. common එකට කියනවා මේ electron එකයි එයාගේ oxygen ගේ electron එකක් දෙකක් අරගෙන they share. එතකොට oxygen ගේ electrons දෙකක් අරගෙන share වුණා. එතකොට 4ක් ඉතුරු වෙනවා. Lone pairs. 2 lone pairs. 3 pairs were there. 1 pair is now shared with hydrogen. Each electron is shared with 1 hydrogen to make stable. Now hydrogen also becomes stable here. 2. Oxygen ගේ වටේ බලන්න 6. Along with the shared electrons, it has made this octet completed. So now look at the oxygen atom. There are 2 lone pairs. No lone pairs with the hydrogen. එතකොට lone pairs දෙකක් තියෙනවා oxygen atom එකේ. Right? 2 lone pairs are found with 1 oxygen atom. So in a water molecule, you have 2 lone pairs in the middle atom with oxygen. Ammonia. Another example of ammonia NH3. So nitrogen, you know, that is in the outermost shell, 2,5. Its atomic number is 7. In the outermost shell, it has 5 electrons, not completed. They need to share 3 electrons. So they take each electron shared with single hydrogen atom. And තුනක් ඕන හින්දා hydrogen 3 දෙනෙක් එක්ක. With 3 hydrogen atoms, they are going to share. So after they sharing, so now you see the nitrogen atom has 3, 4, 6, 8 electrons are there in the outermost shell. So 3 bond pairs and one lone pair which is not participated. So there is a single lone pair. One lone pair is found with nitrogen atom. එක nitrogen atom එක lone pair එකක් තියෙනවා. No lone pairs with hydrogen. We saw that with fluorine, 3 lone pairs. Oxygen atom, 2 lone pairs. No lone pairs with hydrogen, but 1 lone pair with nitrogen. When මේ points තුන මතක තියාගන්න, it will be easy for you to develop the Lewis structure later on. Methane or methane, CH4. So carbon, its number is 6. So it has 4 electrons in the outermost shell. හතරක් තියෙනවා. So they need another 4 electrons to be shared. So now they call with 4 hydrogen atoms. So now they have shared the electrons. So now carbon atom has completed its octet. එයාගේ සම්පූර්ණ කරගත්තා. So no lone pairs with carbon here, no lone pairs with hydrogen. And carbon atom has no lone pairs. Let's take a look at another example, hydrogen chloride. Hydrochloric acid, this is actually hydrogen chloride, right? This molecule. So it's a covalent compound. So chlorine 287. In the outermost shell, they have 7 electrons. They need 1 more to get shared. So they call with hydrogen atom. And then they made a set here. They have made a covalent bond here, 1 bond pair. With chlorine atom, you find in the outermost shell of the chlorine, there are 3 lone pairs, which these pairs were not participated, forming the covalent bond. 3 lone pairs with chlorine atom, right? And if you look at the lone pairs of these atoms which we made, the nitrogen atom had single lone pair, 1 lone pair. Oxygen atom has 2 lone pairs. Chlorine and fluorine has 3 lone pairs. Remember, the carbon and hydrogen atoms, they don't have lone pairs. මේ point 4 මතක තියාගන්න. Lewis structures අඳින්න. මේ points 4 මතක තියාගන්න ඉස්සරහට Lewis structures අඳින්න. Nitrogen 1 lone pair. Oxygen, 1 single oxygen atom has 2 lone pairs. 1 chlorine or fluorine atom has 3 lone pairs, whereas carbon and hydrogen has no lone pairs. Another special example here, oxygen molecule. You see the oxygen atom has, 2,6 එයාගේ වෙන්නේ. එක්කෙනෙක්ට දෙකක් ඕනේ. O2 molecule. This is covalent bond made between 2 oxygen atom. So one type of oxygen atom need 2, the other also need 2. What they are going to share is that they are going to share 2 of the electrons of each to make the bonds. මේක දැන් මෙයාගේ එක එක අරගෙන මේකේ දෙකක් අරගෙන ෂෙයා කරාම මේගොල්ලන්ගේ හැදෙනවා double bond එකක්. So you will see here they have made a double bond here to make octet. So you see 1 oxygen 2 4 6 8, the other also 2 4 6 8. Now these 2 are the bond pairs. Dot and across like this. One from the 1 oxygen, another next electron from the other oxygen. එකම set එකේදී in one set they have 2 bonds here, so we say it's a double bond. So it's a very special case with oxygen molecule. Similarly, you take nitrogen molecule, N2, they have 5 electrons in the outermost shell, they need 3 more, so they make 3 bonds here. 1 2 3 with the same set here. එතකොට අපි මේකට කියනවා triple bond. We say triple bond with nitrogen. Now the nitrogen octet is completed. 2 4 6 and 8. 1 lone pair with 1 nitrogen atom. In here, in oxygen molecule, 2 lone pairs with 1 oxygen molecule. In oxygen atom, in 1 oxygen molecule you have 4 lone pairs and 2 bond pairs. Make a triple bond එකක් තියෙනවා. 1 lone pair with 1 nitrogen. In N2 molecule you have 3 bonds and 2 lone pairs altogether. Take a look at carbon dioxide. So the carbon dioxide, oxygen in the either side of the carbon. So carbon 2 4, they need 4 electrons to get shared. From each oxygen they take 2 electrons. And they have made double bonds here. 2 double bonds. මෙතන double bonds දෙකක් හදලා තියෙනවා. So now the carbon is also completed its octet, and oxygen also completed its octet. So you see no lone pairs with carbon atom. 1 oxygen has 2 lone pairs. So 2 double bonds are found. This is another very special case. එතකොට special bonds තිබුණා පුතා. Oxygen molecule O2 double bond. මතක තියාගන්න. N2 molecule had 3 bonds, triple bonds. මතක තියාගන්න, triple bonds. Carbon dioxide molecule had two double bonds. මෙන්න මේමයි පෙන්නන්නේ bond එක. Lewis structure වලින් පෙන්නපු දැනට, right? Just the bond as line. Just remember this. Oxygen has two double bonds. One double bond. Nitrogen has three double bonds in two molecules, right? Not with one nitrogen atom. This is between two nitrogen atoms, not nitrogen with any other atoms. This is for N2 molecule. Only these three only, right? Carbon dioxide has two double bonds, and all other molecules or the compounds in your syllabus, we make all single bonds between the atoms. Now we want to make the Lewis structure. Lewis structure and the dot and cross diagram for these particular given molecules. අපි දැන් බලමු එකක් අරගෙන මම explain කරන්නම් NH3 ගමු. We take NH3. So there are certain steps to follow in case of drawing the Lewis structure or the dot and cross diagrams or the Lewis dot diagram. First thing is, when a molecule is given for you to draw either Lewis structure or the dot and cross diagram, first of all you find out select the central atom. Central atom එක මුලින්ම හොයාගන්න. Central atom කියලා කියන්නේ more than 2 තියෙනකොට atoms, more than 2 atoms තියෙනකොට පුතා අඩුම එක්කෙනාව single atom එකක් තෝරන්න as a central atom. And then the next step is whether they are special bonds, whether they have double or triple bonds, or they are single bonds. අර මම කියලා දුන්නා O2 නම් double, N2 නම් triple, CO2 නම් double bonds, two double bonds. All others single bonds. The next step is check the atoms whether they have lone pairs or not. Lone pairs තියෙනවද නැද්ද කියලා බලන්න. මම explain කරා nitrogen has got one lone pair, oxygen has got two lone pairs, and then chlorine and fluorine, the seventh group elements. Chlorine and fluorine has three lone pairs, whereas carbon and hydrogen has no lone pairs. Finally, you draw the sketch of the Lewis structure first. Initially, you make the Lewis structure and look at your question. And if you want to convert, if they have asked to dot and cross diagram or the dot diagram, then convert this Lewis structure into dot and cross diagram. එහෙනම් මුලින්ම Lewis structure එක ඇඳලා ඉවර වෙලා pencilෙන් ඊට පස්සේ final answer එක අපි sketch එකේ ඇඳලා ඉවර වෙලා final answer එක අපි include කරමු answer sheet එකේ. So look at the special bonds. Oxygen double bond, nitrogen triple bond, carbon dioxide two double bonds, and the lone pairs. Nitrogen single lone pair, oxygen two lone pairs, chlorine fluorine three lone pairs, carbon and hydrogen has no lone pairs. අපි දැන් බලමු how do you draw the Lewis structure, dot and cross and the dot diagram for the NH3. So first find the central atom. I said single atom. Central atom is the single atom found in a molecule. That means අර තනි එක්කෙනාව ගන්න. NH3 කියන්නේ හයිඩ්‍රජන් තුන් දෙනයිනේ. එතකොට එයා තමයි නයිට්‍රජන් එක්ක බැඳෙන්නේ. එතකොට නයිට්‍රජන්ව central atom කියලා ගන්න. Check whether they have special bonds, double, triple or single bonds. You know that the ammonia is all comes under these cases, O2, N2 or CO2, so they have single bonds. So now you draw the bonds around in which lines. Lewis structure එක මුලින්ම අඳිමු. Lines තුනක් දාගන්න. හතර පැත්තටම right, left, top and down. So now we draw only 3 lines because they have made with 3 hydrogen atoms. So they can make only 3 bonds here with hydrogen. Now add the hydrogen atoms. දැන් බලන්න N එක H තුන් දෙනෙක් දැන් bond වෙලා තියෙනවා. මේ line එකෙන් කියන්නේ bond එකක්. Final step is under Lewis structure, check whether they have lone pairs. So nitrogen, yes, nitrogen has lone pair, one lone pair. Hydrogen has no lone pairs. එහෙනම් අපි දැන් nitrogen ට විතරයි lone pair තියෙන්නේ. Hydrogen has no lone pairs. ඒක දාගමු. මෙන්න nitrogen ට උඩින් lone pair එක දාගත්තා. Hydrogen has no lone pairs here. So this is the Lewis structure of NH3, ammonia. So they have bond pairs with line and lone pairs with dots. This is Lewis structure. The same structure we can convert into dot and cross diagram. Our line එකෙන් මම කිව්වා line එක means dot and a cross. Line means dot and a cross. The lone pairs has dots now. So here we indicate nitrogen as dots, hydrogen as cross. Dot and cross එකෙන් one type of an element as dot now, the other type of element with crosses. So I select nitrogen as dots here, including the lone pairs. ඔක්කොම ටික අපි dot වලින් පෙන්නනවා electrons ටික. Hydrogen ගේ අපි පෙන්නනවා cross වලින්. So this is dot and cross diagram. In case of a dot diagram, we represent everything. All the crosses with dots. All electrons with dots. So this is what the Lewis dot diagram for NH3. So how many bonds are with NH3? 1, 2, 3. How many lone pairs are with NH3? So you see you have 3 bonds here with NH3. 1 lone pair with NH3. Now the central atom is nitrogen. How many electrons are? Let's see. How many electrons are found in with central atom? The nitrogen ගත්තොත් එහෙම මේ බලන්න මෙයාගේ bonds 3ක් තියෙනවා. bonds 3යි. එක bond එකක් කියන්නේ one line means dot and a cross. That means one electron from nitrogen and hydrogen, so that it has 2 electrons. One bond represents 2 electrons, a pair of bond pairs of electrons. So they have 2 lone pairs. So altogether the nitrogen has 2 plus 2 plus 2, altogether 8 electrons. Now the outermost shell of nitrogen is completed. It has got a complete octet. This is how you find the central atom, the number of electrons in the central atom. So likewise, you can draw the structures of CH4, Lewis structure, dot and cross diagram of CH4, hydrogen, H2, H and H, bond pair, no lone pairs. In case of dot and cross diagram, 1 dot and cross for the line. So no lone pairs. In case of a dot diagram, full dot Lewis dot diagram na cross එකෙන් කළා dot එක දානවා. Hydrogen fluoride. Hydrogen and fluorine atoms. Fluorine atom has 3 lone pairs. Hydrogen has no lone pairs, 1 bond. This is, you convert this into dot and cross diagram. So this line dot and across, fluorine as dot, hydrogen as cross. Now take a look at the Lewis and the dot cross diagram of oxygen. අපි දැන් oxygen වල dot and cross එකයි Lewis structure එකයි ටක් ගාලා බලමු. So I ask you to see whether there is a special bond. Yes, oxygen molecule has a double bond, and then we have to check. Now you put double bonds here between the 2 oxygen atoms. Double bond එකක් දාගන්න. And then check for the lone pairs. Yes, 1 oxygen atom has 2 lone pairs. එහෙනම් අපි lone pairs ටික දාමු. So 1 oxygen, 2 lone pairs, right? මේ විදිහට හරහට vertically, or you can make one as vertically or horizontally. මේ වගේ horizontally හරි එක pair එකක් අපිට පුළුවන් vertically දාන්න. Now this is Lewis structure. The same thing, if you want to convert this into dot and cross diagram, what you have to do is, 2 bonds are here. So 4 lone pairs are found in oxygen molecule. This is actually oxygen gas. So now to convert this into dot and cross diagram, as I said, this line represent, the bond represent a dot and a cross, maybe data digata dagana in a vertical way, vertical position. Okay, you just mention like this, the dot and the cross, and one type of oxygen with dot, and the other type of the oxygen, the electrons with crosses. Then maybe the dot and cross diagram you can make it. If you want to convert this into all dot diagram, Lewis dot diagram, remove these crosses and then put dots all. So this is Lewis structure for oxygen molecule, Lewis and the dot cross diagram. You can practice this. Let's look at CCl4 quickly. I'm going to rush up now. We see this Lewis structure and dot cross diagram. So what is the procedure? Select the middle atom. So the middle atom should be carbon here, and then you make the bonds 4 chlorine are attached to it. Check whether there is first, you must check whether they have got double bond or triple bonds. O2, N2, not CO2. So all single bonds here. So carbon is the central atom. So the 4 chlorines are attached to it with single bonds. Next, check the lone pairs. So carbon has no lone pairs. The chlorine, 1 chlorine atom has 3 lone pairs. So you can include the lone pairs now. With 1 chlorine, you have 3 lone pairs. Then maybe the last horizontal, vertical, horizontal, vertical, horizontal, and vertical positions, the lone pairs, right? So now you see, this is the Lewis structure of CCl4. This is called carbon tetrachloride. Carbon tetrachloride. And then If you want to convert this into dot and cross diagram, as I said, may line it up, you show it as a dot and a cross, dot and a cross. Now check whether the carbon is, now we have carbon, we represented as cross, and the chlorine atom is easy for us to represent as dots. Carbon as cross, chlorine as dots. So how many lone pairs are found in this altogether, this CCl4 molecule? So one chlorine has 3, so 3 into 4. So 3 into 4, you get altogether 12 lone pairs in this whole molecule. මේ මුළු molecule එකේම තියෙනවා පුතා 12 lone pairs. Now check for nitrogen. Nitrogen is a molecule. We'll check the Lewis structure and the dot cross diagram of the nitrogen. Check whether they are special or not, whether they have double bond, triple bond. Yes, nitrogen molecule is a special one, which it has got 3 bonds, that means triple bond between the nitrogen atoms. And then we draw the structure here between 2 nitrogen, 3 triple bonds. So special case. Next, check with lone pairs. Yes, nitrogen, one nitrogen atom has a single lone pair. So there are 2 nitrogen atoms too. So we can put the 2 lone pairs on top of nitrogen. Make a metana දාන්නත් පුළුවන්. මෙතන vertically you can put it in the right side and then even in the bottom or top, no problem. But in a අර box එක වගේ දාගන්න. මේම vertical, horizontal, vertical, horizontal, right? So this is Lewis structure. If you want to convert this into dot and cross, so one nitrogen, the electrons in one nitrogen in dot, the electrons of the other nitrogen should be represented as cross. So now we make them to dot cross diagram, dot and cross diagram. So our bond එකේ හැම වෙලේම bonds you should mention as dot and cross, dot and cross, dot and cross, triple bonds all together, right, in one position. Vertically you can represent as this, and lone pairs with one nitrogen I'm going to use it with cross, the other one with dots. So the nitrogen ये පහම දැන් මෙතන connect වෙලා තියෙනවා electrons. So if you take one nitrogen here, it has got 8 electrons, 2, 4, 6, 8. It's completed. Octet. It has a complete octet. So this is what Lewis structure of nitrogen and nitrogen molecule. Special case. Water molecule. Can you try this with you? Can you try with this molecule by drawing the Lewis structure by yourself? Dot and cross diagrams for a try කරලා බලන්න. කොහොමද එන්නේ කියලා. Now check whether there are special bonds. No, H2O is not under the category of special. N2, O2 and CO2, it's not comes under this. So all single molecules, single bonds. Which one is the central atom? We should select oxygen as the central atom. And either sides you can add the hydrogen atoms. Now next you have to check for the lone pairs. So one oxygen atom has 2 lone pairs, where hydrogen has no lone pairs. So now this is Lewis structure. So if you look at the water molecule, H2O means water molecule. So there are 2 bonds here. 2 lone pairs are found in water molecule. If you look at the oxygen, the central atom, 2, 4, 6 and 8. So octet is completed. මේ line එකෙන් bond එකෙන් කියන්නේ 2 electrons. 2, 4, 6, 8. So it is 8 is completed. Complete octet. So this is the dot cross diagram. You can take the same thing, the Lewis diagram එක ඇඳලා ඉවර වෙලා, after you draw this Lewis diagram, you can convert this into dot and cross diagram. So we can show this. I am going to give oxygen dots, hydrogen with crosses. මේ bond එකෙන් කියන්නේ dot and cross. So always when you have a bond like this, it represents a dot and a cross. So likewise, we'll check for the carbon dioxide quickly. Is it a special case? Yes. Carbon dioxide has 2 double bonds. Carbon dioxide to double bond දෙකක් තියෙනවා. එහෙනම් ඉස්සෙල්ලා ඒක ඇඳගමු. So center atom is carbon, the single one, and both sides you can include at the oxygen atoms with double bonds. Now check for the lone pairs. Carbon has no lone pairs, but one oxygen atom has 2 lone pairs. So now I'm going to include the lone pairs. Now this is Lewis structure. Lewis structure, the bond pairs are represented as lines, the lone pairs are with dots. So if you look at the carbon dioxide, it has got 4 bonds, here 2 to 4 bonds altogether, 4 lone pairs. If you look at the carbon, there are 4 bonds here, one line represents 2 electrons, and altogether 8 electrons are with the carbon atom, the central atom. So now the same thing can be converted to dot and cross diagram or the Lewis dot diagram. Make a line, a bond, dot and cross, right? So we give carbon with cross, oxygen with dots. So this is dot and cross diagram. If you want to convert this again to the dot diagram, Lewis dot diagram, එතකොට මේ ටික අයින් කරලා cross ටික අයින් කරලා dot ටික දාගෙන යන්න. Next. So this is how you get the Lewis structure of carbon dioxide and the dot and cross diagram, or if you want you can make it to the Lewis dot diagram as well. When you look at this carbon dioxide molecule, this is the shell structure. Usually they don't ask much on this shell structure. They might ask you to draw the Lewis structure or dot and cross for the dot diagram. Usually they ask Lewis structure or dot and cross diagrams. So now the carbon dioxide molecule, this molecule has 4 lone pairs. Lone pair, 1 oxygen, there are 4 lone pairs. And they have got 4 bonds and 2 double bonds. So this is the story of the carbon dioxide. Can you draw the Lewis structure of aluminium chloride? So as I said, aluminium chloride is, although they are between metal and non-metal, still we consider it as a covalent compound. Can you try? What will be the middle atom here? Aluminium, yes. Make a balance aluminium gattama puta. Aluminium has got 283. So in the outermost shell it has 3 electrons. So all 3 electrons are contributed for the sharing with each of these chlorine atoms. Chlorine ekke share vela තියෙනවා. එතකොට no lone pairs with aluminium atom. Aluminium middle atom has no lone pairs. All 3 outermost electrons in the outermost shell are now shared with the chlorines. So one chlorine atom has 3 lone pairs, as we have mentioned earlier. So this is the Lewis structure of aluminium chloride. But look at the aluminium here in the middle of the aluminium. May aluminium එක බලන්න. Sorry. So when you look at the aluminium here, right? So it has 3 bonds here, no lone pairs. So altogether, 3 bonds means 1 bond represents 2 electrons. 2 plus 2 plus 2, only 6 electrons are found in the middle atom. The middle atom එක aluminium එකේ 6යි තියෙන්නේ. So not 8. So we said such molecules as incomplete octet. Incomplete octet. මෙයාගේ මැද 8 වෙලා නැති හින්දා aluminium ගේ අපි මේකට කියනවා incomplete octet. So can you draw the structure of beryllium fluoride? Lewis structure. So hold the video, try it. So there are, so this is another example, PCl5. This is another example for incomplete octet of electrons in addition to aluminium chloride. So PCl5. So phosphorus is combining with 5 chlorine atoms. So you look at the phosphorus. So 5 bonds. That means 10 electrons. So more than 8. So this is also known as incomplete octet of electrons. And aluminium chloride and PCl5 are examples. Did you draw the structure of beryllium fluoride? Beryllium fluoride. So beryllium gattama atomic number is 4. So the configuration 2-2. 2-2 තියෙන්නේ. In the outermost shell, it has got 2 electrons. So both of these 2 electrons are now shared with the fluorine atom. So no any lone pairs with beryllium. So fluorine, one fluorine atom has 3 lone pairs. Now this is the Lewis, not Lewis, this is dot and cross diagram. Now look at the beryllium atom, the central atom. How many electrons are around it? මේක වටේ දැන් කීයක් තියෙනවද? 2 4. එහෙනම් 4යි තියෙන්නේ. It is also one of the incomplete octets. මේකත් එක incomplete octet එක, beryllium fluoride, and also the beryllium chloride also same. So this is how we draw the Lewis dot and cross, dot and cross diagram and Lewis structures and Lewis dot diagrams. Let's move on to the next part. That is on atomic lattice. We learned on ionic lattice. Ionic lattice are found between ionic compounds, sodium chloride. Do you remember? But remember, the lattice is also found in some covalent compounds. Especially graphite and diamond are good examples for atomic lattice. අර වගේ lattice එකක්, අර වගේ crystal form එකක් වගේ solid structure එකක් හදනවා covalent compounds වලින්. Graphite and diamond. Right? So you know the graphite and diamond are the allotropes of carbon. So graphite conduct electricity, you know that. Diamond is the hardest substance among these elements, right? So this has high melting and boiling point, whereas generally the atomic lattice, the covalent compounds do not have high melting and boiling point. But this lattice forms has got high melting and boiling point. Let's take a look at this graphite. This is diamond, you know that. If you look at the structure of the graphite, so they are combined with this one, make it them one dot is as carbon atom here. So one carbon atom is combined with 3 carbons here. So this carbon is connected with 3 carbons. So one carbon is connected with 3 other carbons. Only 3 bonds with a single carbon. Carbon එක වටේ 3 bonds තමයි තියෙන්නේ. එතකොට මෙයාගේ 4ක් තියෙනවානේ. Carbon, you know, that is 2-4 configuration. It should have 4 electrons, but they have made covalent bonds with other carbons with 3. එතකොට එක electron එකක් graphite වල ඉතුරු වෙනවා. So one electron will spare here, right? So that will be act as free electron. අපි ඒකට කියනවා free electron කියලා. So you get free electrons in this graphite. මෙන්න මේක free වෙනවා. So one carbon has got one free. So all these carbon atom will get free electrons. These free electrons are negatively charged. So when you give a potential difference, this electron will start to flow. So that is what we say the current flowing. So actually the flow of current means that is current electricity means flowing of free electron. So the graphite has got free electrons. So that is why graphite conduct electricity. So this is the structure of the graphite. So you should be able to identify the structure when the diagram is given. So these are layered. මේක නිකන් layered වගේ තියෙනවා. තට්ටු වගේ තියෙනවා. graphite හඳුනා ගන්න පුළුවන් ක්‍රමයක් තමයි තට්ටු වගේ තියෙනවා. So this the layers act as gives a lubricant property for the graphite. So graphite, the diamond is a 3D structure where you have the one carbon is connected with 4 other carbons. So this is a 3D structure and this is hardest substance found in the nature, diamond. එන්න බලන්න මේක දැක්කම diamond කියලා හඳුනා ගන්න පුළුවන් වෙන්න ඕනේ. You should be able to identify the structure of a diamond when the diagram is given. So this is carbon, diamond, one of the allotropes of carbon, diamond. So graphite and the diamond. And we learned before ionic lattice, sodium plus and chloride ion. Here you don't get any ions here. Carbon කියන්නේ ion එකක් නෙවෙයි. These are covalent bonds. They make between them covalent bonds. These ionic bonds. Now number 43, they are asking state examples for ionic lattice and atomic lattices. You know ionic lattice is sodium chloride, ionic compound. And atomic lattice අපි දෙකක් ඉගෙන ගත්තා, that is between covalent compound you find this atomic lattice. Graphite and diamond are examples for atomic lattice. So take a look at this question. PQR are 3 diagrams. So you need to find out the substance, what is P, what is Q, and what is R. And the type of the lattice. So example is given, Q is as atomic lattice. And you need to find out the type of the bond shown. As here alpha sign, this is beta sign. Please try to write the answer. I'll show you the answer to check. Yes. So P is diamond. It is an atomic lattice, and Q is a graphite. So layered form is an atomic lattice. So this is sodium chloride. It is an ionic lattice. So the bonds of alpha are covalent. So the beta here with sodium chloride ionic bonds. Another question, state the reason why do graphite conduct electricity. I said the carbon has got 3 carbon atoms. Carbon is combining with the other carbons, only 3. So one electron, there are free electrons, so that they have free electrons, so which help to conduct electricity. So this is the reason. Right. So now we are going to explain another very important information, that is about polarity. Very important, right? So you know that covalent compounds are made between sharing of electrons. If these atoms are same, if the covalent bonds are made between the same atoms, like hydrogen and hydrogen, fluorine and fluorine, nitrogen and nitrogen, same kind, we say those types are homoatomic molecules. Homoatomic molecules. Same, homo means same. Then hydrogen and hydrogen, fluorine and fluorine. Let's look at these the electronegativity differences. Now we say that these homoatomic molecules have no electronegativity difference. They have electronegativity, but the difference of the electronegativity. When they don't have electronegativity difference, we say those type of molecules as non-polar. They are non-polar molecules. අපි බලමු මොකද්ද මේ electronegativity difference කියන්නේ. Look at the electronegativity is, you know, that ability to attract electrons when they have a covalent bond. So this is the Pauling scale of certain elements based on your periodic table. So hydrogen has 2.1. If it is combined with another hydrogen, so it's where electronegativity also 2.1. So what is the difference if they are made with H and H? H and H තිබුණොත් H and H bond එකක් තිබුණොත් දෙන්නගෙම 2.1 2.1 difference is 0. Similarly, if you take N and N, nitrogen and nitrogen, 3 and 3 difference එක දැන් 3යි 3 අඩු කරාම you get 0. O2, F2. So if they are homoatomic, that means combined as same atoms, same kind. So we say they don't have electronegativity difference. They are non-polar. We say they are non-polar. Right? එන මතක තියාගන්න එකම ජාතියේවා තිබුණොත් අපි ඒවට කියනවා non-polar කියලා. Right? Next. Heteroatomic molecules. These are the covalent bonds made with different kind of atoms. H2O, HF, NH3, CH4. මේගොල්ලන් වෙනස් හින්දා ඒගොල්ලන් electronegativity difference එකක් තියෙනවා. They have an electronegativity difference because they are not homoatomic. If there is a significant electronegativity difference, we say they are polar covalent compounds. We say they are polar covalent molecules or compounds. If there is a significant electronegativity difference, let's see one by one. Hydrogen and oxygen. Hydrogen and oxygen difference එක බලන්න 3.5 and 2.1. Hydrogen and oxygen ගත්තම 1.4 වගේ තියෙනවා different එක. So they have a significant electronegativity difference. H and F, it's around 1.9. ඊට වඩා වැඩිය තියෙනවා. And N and H පොඩක් අඩුයි 2.1 and 3, that is 0.9. If you look at carbon and hydrogen difference is 0.4. This is not that significant difference. එතකොට මෙතනට යන්න electronegativity අඩුයිනේ. එතකොට අඩු හින්දා මේ අර difference එක අඩුයි. දැන් මෙතනට යන්න. ඒ කියන්නේ periodic table එකේ fluorine පැත්තට යනකොට electronegativity is higher. Compared with the hydrogen, difference is more. Right? So that H and H non-polar. So electronegativity of 1.9 between H and F, they are polar. H2O, water is a polar. HF is a polar. HCl is a polar. But can you guess now whether CH4 is polar or non-polar? Yes. I said only 0.4 means the negativity difference is not that significant, so that we consider CH4 as non-polar. Non-polar because its electronegativity difference is not that significantly different. And remember the compounds containing carbon and hydrogen, as I said, hydrocarbons, so they are non-polar. Carbon, hydrogen, are non-polar because their electronegativity difference is less. Although they are heteroatomic, we have to consider the difference. Now, can you write the ascending order of following molecule based on polarity? Make a the polarity aduma polarity vadima. Can you rearrange this as ascending order of polarity? What do you think about fluorine? It's a homoatomic, so the electronegativity is least 0. Carbon and hydrogen. Next, I think NH3. Yes, it has a polarity. When you compare HF and H2O, HF has highest difference. So make a heduama mena me wage none. So these are non-polar. H2O more than H2O, HF is high polar. But when you compare with H2 and HCl, etanadi H2 ege polarity එක නැත්නම් අර attraction මේ sorry HF and H2O, so HF has higher negativity when you compare with the oxygen, so the polarity is greater here, right? So as a summary, the polarity of bonds, non-polar molecules are between homoatomic, so no any electronegativity difference. But polar compounds have significant difference. If you look at the water molecule, it's a very special molecule. We consider it as a polar. Can you explain how do you say the water molecule is polar? So this is the explanation. What is the explanation? Now look at the water molecule here. The oxygen is the middle atom. Both the hydrogens are here. So electronegativity is more with oxygen, so ability to attract the shared electrons by oxygen is greater. So this will be attracted towards oxygen. So that what will happen? Oxygen may electron we say the oxygen becomes slightly negative. Negative electron, where any electrons are negatively charged. So when you attract electrons, you become negative. So oxygen become not like ionic compounds, but slight negative charges develop here. So hydrogen may share electron right? But it didn't donate, but it has to give up sometimes. So now we say the hydrogen is not donated whole to both the electrons, and they have become H+. But due to this electronegativity difference, this hydrogen ion, right, this attraction, since this oxygen has attracted more, so this becomes H+, H slightly plus, not full plus. So slightly the hydrogen atoms become positive, where the oxygen atoms become negative. So this kind of presence of negative and positive charges, maybe slightly or not, we say they are polar compounds. The reason for this is because of the difference of electronegativity. When there is a significant electronegativity difference, the shared electrons in covalent bonds are attracted towards one of the atoms. That is, the more electronegative atom will pull it. So now this becomes slightly negative. We show the sign slightly negative as delta sign here. Delta sign generally, right? Delta sign this is delta negative, means slightly negative, slightly positive, delta plus. Because of this attraction of electrons, because of this polarity, the water molecule will make a angular shape. So this has a degree of 105. degree make angle, right? So this will make an angle of 105 generally. You don't want to remember the values, but this electronegativity, this polarity of water molecule gives angular shape. So that is why when you draw the Lewis structure, the dot and cross diagrams for water molecule, we don't write it in straight, but we make it a angular shape. Angular shape Lewis structure water molecule. So how do you explain this? Why the water molecule is polar? When OH bond of a water molecule is considered, the bond pair shift more towards more electronegative oxygen atom. So this molecule becomes polarized. That means oxygen atom becomes small negative charge while the hydrogen atoms become small positive charge. So that we say water is a polar covalent bond or compound. මෙන්න මේක තමයි කියන්නේ H plus වෙනවා මේක H minus වෙනවා. So this is a very important information that you should remember. What is the special bond found between water molecules due to this intermolecular bond? You know that water molecule එක දැන් ගත්තම oxygen එක slightly negative, hydrogen is slightly positive. So between the water molecules, if we say here you have 3 water molecules here, right? The water molecules are found here. So this is slightly positive, H plus, O slightly negative. So now what is going on between the water molecules, the H plus and O minus, they will develop another kind of an attraction between the water molecules due to this slight negative of oxygen and slight positive of hydrogen. So this bond is, in addition to the covalent bonds, they make this type of a bond between the water molecules. We say intermolecular bond. අපි මේවට කියනවා intermolecular bond කියලා. So the special bond between the water molecules are, we say, intermolecular bonds. මේවට අපි කියනවා intermolecular bonds කියලා. Right. So remember that between the water molecules due to polarity. So look at this diagram. So you will see intermolecular bonds between water molecules. The covalent bonds are between O and H. Intermolecules are bonds are between the molecules. Intermolecular bonds also known as hydrogen bonds. තව නමකින් දෙනවා hydrogen bond කියලා. So this diagram shows a very clear explanation of this covalent bond and the hydrogen bond or intermolecular bond between the water molecules. So because of this hydrogen bond or intermolecular bond, water has got special properties. Let's see one by one. So water is present as liquid at room temperature because of this intermolecular bond. මෙන්න මේ intermolecular bond ಇಂದ water ට ලැබෙනවා special. So water will get a special bond called due to this intermolecular bond, they get water present as liquid at room temperature. So this is a very important fact. You know why? If there is no intermolecular bond, if there is no intermolecular bond, remember, you don't have water to drink. So all water will become vapor if there is no intermolecular bond. මේ intermolecular bond එක නිසා තමයි අද liquid විදියට තියෙන වතුර, නැත්නම් there is no origin of life without water. So this bond is very, very important. And also because of this, the water molecule get high boiling point due to the presence of this intermolecular bond. The water molecule will get a high boiling point. High boiling point එක ලැබෙනවා වතුරට. Water. You know the water 100 Celsius. Generally the other covalent bonds, the boiling point is less, but water has a high boiling point when you compare with the other covalent bonds. Generally they are gases: oxygen, carbon dioxide, nitrogen, methane, ammonia. So they are gases except the lattices, right? May graphite and diamond hair අනිත් ටික ගත්තම their boiling and melting point is less, but compared to them water has a high melting point. And also water has high specific heat capacity. This is another important information. So to heat water you need to supply a high energy. So specific heat capacity means if you take water of one water අපි 1 kilogram එකක් ගත්තම, if you take 1 kilogram of water to raise its temperature, you need 4200 joules of energy. So it's a very massive energy. So you cannot heat water easily. So this property gives to water to act as a cooling agent. මේක මේ cooling agent එකක් විදියට වැඩ කරනවා මේ, especially in water as a cooling agent. You know the vehicle engines, they use this water coolant because it absorbs a high energy, still it does not boil. And another special property that the water has got due to this intermolecular bond is that the the density of ice is less, the water is more. That is also due to this intermolecular bond. So because of this property, ice floats on water. So we say that expansion difference upon freezing. This property we have learned in grade 10 unit 1 under the properties of water. Because the density of water is more than the ice, so ice floats on water. That is important for the aquatic organisms. Still they can survive under very less temperature. And also it's important, the water is important to maintain our body temperature also, right? So these are the main features of special properties of water due to the presence of intermolecular bonds. Liquid at room temperature, they have high boiling point, high specific heat capacity, and ice floats on water. Right. Now, the last topic on this ionic and covalent bonds is regarding these characteristics of ionic and covalent compounds. So there are certain characteristics. Among them, we'll first look at the conductivity of electricity of both ionic and covalent compounds. So we'll do a small experiment here. So this is the setup of an experiment to show that the conductivity of electricity in a solution. So if the solution conducts electricity, so the bulb will light up. If the solution do not conduct electricity, the bulb will not light up. So these are electrodes, carbon, these are graphite electrodes, they conduct electricity, and the conductors are connected, the bulb is connected here, and the dry cell is used to give a potential difference. If the solution conducts electricity, the bulb will light up. Let's take a look at ionic compounds. The solution of ionic compounds. Any solution of ionic compounds, they conduct electricity. If you take sodium chloride, dissolve in water, you get the aqueous solutions. Aqueous. And then, so they have mobile ions here. So through this solution, the electricity will conduct. So all these ionic compounds at aqueous state, when their state of matter is aqueous, that means they are dissolved in water, they conduct electricity. But the solutions of covalent compounds, remember, they don't conduct electricity. Solutions of covalent compounds do not conduct electricity. Sugar solution, kerosene, petrol, distilled water, right? They do not conduct electricity. And another important fact is that solid form of ionic compounds, that means that solid forms, not dissolved, right? Solid crystals form of ionic compounds do not conduct electricity. Why? Because why they don't conduct electricity? Even though they are ionic compounds, the solid form do not conduct electricity. Why? Because they do not have mobile ions. So solid forms they are packed tightly, so you don't get free ions there. Movable ions are not formed, so that they do not conduct electricity. But if you can make this solid to fused form or molten form, fused means right? So now you heat it, not dissolving in water, you heat it and make it a liquid upon heating. So this we say fused form or molten form. So that is molten. Even sugar you can make it to caramel. Without adding water, you can make it to liquid. So those phenomenon we say molten or fusing or fused ionic compounds. So these fused ionic compounds conduct electricity. The bulb lights up. So molten means ionic compounds making into liquid upon heating. Aqueous means just dissolving in water. So remember, solid ionic compounds do not conduct electricity, while the aqueous and molten ionic compounds conduct electricity. Covalent compounds, anyway, they don't conduct electricity. Now state which of the following solutions conduct electricity, you can observe whether the bulb lights up or not. Now can you do this and let me know? Aqueous sodium chloride, do they conduct electricity? Right? Fused molten sodium chloride. Sugar solution, distilled water. Distilled water means there is no any other minerals or ions, just only H2O molecules. Acid water means when the water is added with drops of acid, we say acidulated water. Distilled water means nothing. Mineral water wala pala ions they may conduct electricity. Even the acid rain, the rain also get acidic. So they may have got electricity. But distilled water do not conduct electricity, only covalent compounds. So you know how to identify the ionic and covalent compounds based on the explanation given before. So now try to get this answer. Diluted HCl. HCl is covalent compound, but remember, when the HCl is dissolved in water, they become acidic. They are acidic generally. But acids conduct electricity. So diluted HCl is an acid. Acids and bases generally conduct electricity. Kerosene, petrol, they are hydrocarbons. They are not polar and they do not conduct electricity. They have what? Covalent compounds. Salt solution conducts, yes. But solid sodium chloride do not conduct. So try to answer this question with the reasons. Copper sulfate, yes. Sulfate, no. It's a polyatomic ion, ionic compound. They conduct electricity. Sodium hydroxide is a base. OH is a polyatomic ion. They conduct electricity. So remember, generally acids and bases conduct electricity. Kerosene, covalent compound, do not conduct electricity. Petrol, no. Acidulated water means acidic water. That means you add acids, so they conduct electricity. Salt solution conduct electricity. Sodium chloride, solid form, do not conduct electricity. As I said, absence of mobile ions. Molten form of ammonium hydroxide means that is ionic compound. Ammonium, that is a polyatomic ion, so they conduct electricity. So remember, covalent compounds do not conduct electricity. Ionic compounds conduct electricity. Among the ionic compounds, remember, solid form do not conduct electricity. Let's see the characteristic of ionic compounds quickly. Generally, the ionic compounds are solid. They form ionic lattice. They have high melting and boiling point. So ionic compounds have high melting and boiling point. So generally, if you take sodium chloride, if you want to melt it, you need about 850 Celsius degree. You can gas slipping melt current back. It's a very high temperature required. Solid form do not conduct electricity in ionic compounds. So only the fused form and aqueous solution conduct electricity. They are mostly soluble because they are polar. Ionic compounds are polar. Positive and negative ions, they are polar. So most of them are soluble in water. Covalent compounds are generally gaseous or liquid state. They found originally as gas or liquids. But the lattice forms like the diamond and graphite are solid. Generally, they have low melting and boiling point except the lattice compounds. Only some compounds are soluble in water. Polar compounds are soluble in water. Generally, they do not conduct electricity. Now, we'll see a small experiment quickly to show this, how the electricity is conducted in these solutions. So you can see the diagram here. So these are the dye cells, and then the battery is connected with a wire here. So these are the graphites, methane graphites DNA. So the bulb is connected here. Now let's see one by one the solution. You see, when the graphites are combined together, the electricity conducts. Now we put into distilled water first and see whether the current pass through this solution. So you see there is no bulb is working, bulb is not light up. No lights up of bulb, no conduction of current, electricity. Now you add acidic water, acidulated. So some acids now you become acidulated water. These conduct electricity. Acidulated water. Podakara distilled water acid it conducts electricity. Right. Let's see. We add some. This is distilled water again. Distilled water means nothing, only water molecules. Now we add copper sulfate. Copper sulfate is ionic compound. So now you dissolve in water, it becomes aqueous copper sulfate. And then you check whether the current passing through this solution or the electricity is conducting. So definitely the bulb will light up here because the copper sulfate is ionic compound with aqueous form. solid form na යන්නේ නැහැ. solid එකට මේ graphite එක තිබ්බම මේ electrodes තිබ්බම වැඩ කරන්නේ නැහැ bulb එක. So you see here, bulb lights up. That means the electricity is passing through this solution. And we take the distilled water again. We add some sugar, table sugar. You know the sugar is C12H22O11. It's a covalent compound. So when you dissolve in water, it makes covalent solution, compound solution, but it does not conduct electricity. මේකත් electricity එක conduct කරන්නේ නැහැ. The bulb will not lights up here. Right. Now let's check with salt, sodium chloride. So again, you know that is sodium chloride is a lattice, ionic lattice. They dissolve in water because they are polar. They makes aqueous solution of sodium chloride. You know, definitely the bulb will light up. The current will go through this solution. Right. So these are the things you learn. And then what we have done in this whole chapter on chemical bonds, we said the types of bonds, ionic bonds and covalent bonds, and then we learn to draw the ionic structures and covalent compounds, Lewis structures, dot and cross and dot diagrams. We learn how to draw them, and then the characteristics of ionic compounds and covalent compounds. So this is a summary of ionic and covalent bonds, and also we learn about special bonds, that is especially the intermolecular bond between the water molecules, and we learn about polarity and non-polarity. So we get a good explanation, and we have explained you a lot on this. I hope you understand this part of the lesson, chemical bonds. So please subscribe and share with your friends, and thank you very much for watching. Wish you all the very best.